Alright guys, so let's go over the warm-up for day 1 of our Unit 6. Okay? First thing, chances are you studied this in geometry close to like April or May-ish. And by then, a lot of us are ready for summer. And unfortunately, this material is highly tested, especially on the ACT. Okay? So what I have 2 regular hexagons, and just to remind you that regular means all the angles are the same and all the side lengths are the same. So a regular hexagon, something like this, all of these would be equal. Okay? All of these angles would be equal. To find the area, you could divide this out into many equilateral triangles and then multiply by 6, or you can just do the fast way. Okay? So I have one where the sides are 8, and I have another one which could be a bigger replica, and it's basically the carbon copy, but it's bigger where the sides are 12. And we want to know what is the ratio of the area of the larger to the smaller. So larger to the smaller is the same as larger to the smaller. Okay? So here we go. If the larger side is 12 and the smaller side is 8, we could look at this almost like 12 over 8. And if I divide by 4, we get 3/2. And some of you might have put that. But that would be the that would only be for the ratio of the sides. It's not the ratio of the area. Okay? Because the side lengths are one-dimensional. The area is two-dimensional. And the volume is three-dimensional. So that means this side ratio that you get belongs here. Okay? It also belongs here and here, but the difference here is that the area is squared and this would be cubed. How many of you actually remember that? Okay? So a little bit less of what I thought would remember. So the side ratio is 3/2. So the area would be 3 squared over 2 squared, which would give you 9/4. So you should have got 9/4 as the answer. I didn't even have to do any triangles. I didn't have to do 1/2 times base times height to get one of them, and then multiply by 6 because there's 6 of these. I didn't have to do any of that, and then find the ratios. I just remembered one-dimensional, two-dimensional, three-dimensional, squares, cubes. Okay? The second one should have been fairly easy. We're just looking at simplifying the expression, and it wants to test, do you know what happens when you have 2 negatives right next to each other? So I have this negative here and this parentheses negative, so I'm really adding x. So if you subtract, what do I get? -11. That should have been an easy one, okay? Now let's go to 13. I have a system of equations, 2 lines. How many answers could I have with 2 lines? I could have 1, I could have 0, or I could have infinite lines, because they lie right on top of each other. Remember that? Okay. So elimination method tells me I could multiply the bottom by a -5. I know it's been a minute since we've done this, and I would get that. The top stayed the same. Those of you who didn't forget, elimination is adding, and these would go to 0. I just eliminate one of the variables. So adding the other ones give me -13y and -39. Y, anyone, is what? 3. Because I have a y left over, and I could even stop here, because I had a y left over, which one of these will the answer be? 1. Nice. So it's just one answer. If I didn't have this y left over, and they both canceled out, let's say it was 0 on the left and it was negative 39 on the right, is this a true statement? So if I ended up with something like this, it would have been no solutions. You with me? Or if I ended up with negative 39 for some reason on the left side and on the right side, or I had 0 and 0, are those true statements? Yes. So then it would have been, don't do too much work if you don't have to. Okay? Yes?
Another way I did it was I just subtracted the two from each other, and if I got something, that meant they crossed over. And if I got 0 on both sides, that means infinitely many.
So you subtracted 2 from both? I don't understand.
So I moved the first equation all on one side of the equal side, and then I did the same thing with the second one, and I set them equal to each other.
Okay, so let me catch up to you. You did this, and then you did that, and then?
And then I subtracted, and I got an equation, so that meant that they did cross over. Because when I got 0, that meant it was true, and that means they're the same equation, so it's infinitely.
I see what you're saying. But what did you subtract from right now? What was the number that you chose?
I just like moved the 5x to the other side, and then the y to the other, and then the negative.
Can you come up here real quick? I can't follow. I want to see if this, I want to make sure that this is good, because if it helps you, yes, use it. But if it's not mathematically sound, I want to make sure I help her real quick. So she added 5. Subtracted 3. And added 4. Okay? So 6x minus y minus 3 is equal to 0.
If I got 0 equals 0, that means they were the same equation, so they always overlap. And if I got, but I couldn't check for no solution though, but I could check for the.
Okay, so you see what she did? She set the equations equal to each other, but the only thing she could check for on that was the ones where the lines are coinciding, infinite solutions. I would prefer you to do the elimination because the way you're tested on ACT, okay? Because sometimes they'll ask, what does this number have to be in order to make it infinite solutions? Or what does this coefficient have to be in order to make it no solutions? So please go with the elimination method because you can see more from that. All right, so now let's go back to 3rd grade. Okay, biggest reason why I love math, and just math is like a 1 on a scale from 1 to 10, just FYI. Music is my 10. But I still love math. I still love math a lot. The reason why I love math, and the reason why I feel a lot of people struggle with math if you don't love it, was 3rd grade. 3rd grade is so important, okay? So if you had a 3rd grade teacher, and you can picture your 3rd grade teacher right now, and that 3rd grade teacher pushed you, did not let you use the calculator, made you show all this work, and you were so upset with that 3rd grade teacher, I promise you, this is going to be easy. This unit is going to be extremely easy, okay? And if you didn't, we're going to catch up, okay? Here we go, watch. 1, 2, 3, 4, 5, 6. That's easy. Okay? What am I doing right now? I'm counting by 2's. So what am I doing right now? I'm counting by 2's, right? So we could call this, if I'm counting by 2's, we'll call it 2n. Okay? Or 2x, however you want to do it. Now what am I doing? Counting by 3's. We'll say 3n. Now tell me what I'm doing. Here we go. Anyone see it yet? Those of you who saw it fast, this is going to be easy what we're doing today for sure. All I'm doing is I'm squaring it. 1 squared is 1, 2 squared is 4, 3 squared is 9. You with me? 4 squared is 16, so on and so forth. Are we good? So we could say n squared. Any questions so far? All right, so now let's test you. Okay? So I want you to count by odds, and all I'm doing is stretching your brain right now. We can say we're stretching before we work out. So we're going to count by odds, and we're going to go positive, negative, positive, negative, positive, negative. Okay? And just stay with my hand movements, and we'll do it together. So here we go. We're going to start with positive. Here we go. Ready? Going by odds. 1, positive 5, negative 7. Okay, good. So you're thinking as you're going, and that's good stuff. Now let's do just the squares. Okay, we're going to start with 1. This one's going to stretch your brain more, right? Let's warm up a little bit. Let's go by 3s. Ready? Starting on 3. Positive the whole time. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, good. Let's count by the squares now. We're ready. Ready? Here we go. Starting with 1. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. Yeah, and we'll stop. So some people started to kind of go off after 64. They're like, oh, or maybe after 81, right? You got to bring that back, guys. The faster you bring that back, this is easy. Okay? Now let's try this one. We'll start with 1. 1, 2, 3, 5, 8. You with me? 13, 21. So Fibonacci, where you add the previous number to the number to get the next one. So to have gotten this 5, I need to add the previous one together in order to get 5. I have to add the previous 2 in order to get 8. So we'll go a little slow on this. You with me? We're going to start at 1. Okay? So we'll say 1, then we'll say 2, then we'll say 3, then we'll say 5, and I'm just stretching your brain. Okay? Here we go. Ready? 1, 1, 2, 3, 5, 8, 13, 21, 34. Nice. All right. Good stuff. That's good stuff. Because when we do this, this is going to be very, very simple if you were able to do that exercise just to warm up, okay? All right, so what I want you to do right now is I'm going to pass out these sheets on your table, and we're going to play some bingo, okay? There are 3 columns. Listen, there are 3 columns of 13. So there's 13 numbers in 3 columns, a total of 39 numbers. And all I want you to do on your bingo cards is pick any one of these and only pick a number one time, okay? You can't pick a number for all your squares. And the goal, we're going to play bingo. When we play bingo, you have the free right there. You can make a bingo if you have all 5 in a row, all 5 in a row, or all 5 through the diagonal. You should have at least 5 to make a bingo. If you get 5, I'll give you 500 points. Cool? And just count out bingo. Any one of these that you're going to fill out. I'm giving you the sheets right now to your groups. Y'all can pick any one of those in random order. And you're going to put them randomly on your bingo cards. Okay? Any one of these. For instance, you have on this sheet, you have 2 root 3, 2 root 2. Now, the way it's going to work, guys, is I will say a number. So look up here, please. I will say, let's say I say square root of 100. If you wrote down 10, then you would simply like put a circle or something there to say, yep, he called 10 out. Let's say that I said, what is the square root of 75? What you're going to do is you're going to simplify this. Guys, what do you see right now when I say square root of 75? What two numbers multiply to give me 75? That are kind of like screaming at you. 25 and 3. And the reason why these should have been screaming at you is, what number is here, guys? What number is understood right there? 2. This is the square root. You with me? Now look, I'm helping you out. I could have written it like this. All of these are the same 75. And because of this, we're going to call it the nether portal, okay? We're going to go through the portal and come out if I have a group of 2. You with me? If I had the cubed root of, let's say, 125, then I could pull this one out because it's going as a group of 3. Okay? So let me give you an example. We're only doing square roots right now. 75 would go to 3 and 25, and I could write that right here. And if I'm taking the square root, this 25 will come out as a 5, and this is what you would have on your bingo card. So if I call this, then you just check that off. Cool? Let's do one more and then we'll start. Let's say that I had the square root of 72. Some of you can see it already. What numbers are there? So someone said 9, someone said 8. Here's what I'll say. When you do prime factorization, it tends to help you with the bigger numbers. For instance, what's the first prime number that you know of? 2. Because a prime number is when a number times 1 gives you the answer. Okay? These cannot be the same. That's why 1 is not prime, because these are the same. You with me? So a prime number is when the divisors are only itself and 1. You with me? So here we go. After 2, what's the next prime number? 3. Okay? Not 4, because you could divide that 1 and 4 and 2 and 2. You with me? So it'd be 5, 7, 11, 13, 17, and so on and so forth. Those are primes. Now, when you do prime factorization, guys, if you're struggling right now, I'm going to say go to 2. Go to 2. It'll help you big time. And if 2 doesn't work, then go to 3. If 3 doesn't work, go to 5. And that should be about it. 2, 3, and 5. Okay? So let's go to 72. I know people said 8 and 9. I know that. But I'm going to go to 2 and 36. And look at that. It's already screaming at me. Can I take the square root of 2? No. But can I take the square root of 36? Yes. What will it come out as? A 6. So if I say out loud, square root of 72, you're going to find it simplified on your bingo card and put a check. First one to 5 gets a bingo, right? We'll get 500 points. All right.